Good afternoon, everyone. Thanks for setting up this wonderful session again. Okay. Um, so we will learn about RAG today, but before that, let us discuss about LLMs first. Um, so I hope by this time all of you would be knowing about what is an LLM and how does it work, and why is it called a language model? How is it different from a normal machine learning models and all? What is generative AI? All those things we will be knowing. So with that background, we will jump into today's session. uh, I just wanted to ask, a few questions. If anybody already knows, just answer to, you can provide your answers. Uh, First, can someone tell me how, what is the basic idea behind a large language model or an LLM? How does it work? What is the core functionality or feature of a LLM? Anybody can say anything. It doesn't matter if your answer is wrong. I just want to make it interactive. So, what is the core feature or function, or the basic thing that LLM does?
Tokenization
Tokenization.
is
That
one of
is
the part.
that's the background part. But what is the core
Pred-
functionality in the sense? What is
Prediction,
actually giving you? Yeah, prediction,
predicting the text, follow up text based on the context.
predicting the
Prompt
okay.
and fine tuning.
So yeah, predicting the text is kind of close. That is the core feature of it. Prompt is what you are giving to an LLM. Fine tuning is all an advanced concept that you will how to make your LLM work better. So basically, yeah, that's a good answer. Uh, Basically, an LLM is nothing but it is going to predict your next word or a sentence or whatever you can call it. What comes next? That is what is the prediction of an LLM. So this is so LLM is trained by giving a lot of information that is available on the public. So they have, I mean, they would have trained with a lot of documents, anything that is available, in the digital format. You take that and create an LLM. So behind creating an LLM from the scratch, there is a lot of work involved. There's a lot of concepts involved. We will not go deep into that, but what we understand is, end of the day, they have trained it in a way that you type something, right? You say a sentence. Let's say the sky is my sentence, right? The sky is. I want it to predict the next word that comes after that. So there are different possibilities. The sky is blue, the sky is red, the sky is beautiful. There are many things that it can generate. So basically, an LLM does that. It tries to predict what comes next after it. That is how a basic LLM based model, you can call it, is first created. Then after that, they train further on it to answer questions, right? So training an LLM, first, it's like they give you, let's say if you have a sentence like the sky is, first you will have the, okay, the is given as the first input, and they will train to say that, okay, if the comes, then next word should be sky. Then if first two words are the sky, then the third word should be is. If the sky is the first, first three words, the fourth word should be red or blue or whatever, right? So this is how they have taken the documents. They have given this document text as input, and that is trained to predict the next available words. So this is called kind of a completion model. Okay, you can call it a completion model. It's like auto, suggesting the next word that appears. That is the base model. So this is not useful for answering your questions. So it is just predicting your next words, right? uh, Keeping this as a base model, they have come up with some more tuning on it or further training on it to answer questions based on what it already knows. So whatever now is trained is the knowledge. So they have trained it with knowledge from the documents, right? So these documents or any information that is available, they have trained it like if this is the first word, this should be the second word. This is the first sentence, this should be the next word that follows. This is how it has learned the information. The knowledge behind LLM comes through this, comes by this. So whatever documents they have taken, they have trained it like to predict the next word by giving the next word and and the follow-up word and so on. So now it has a built-in knowledge, right? So this knowledge is static knowledge with which whatever documents that they have trained. They have trained with millions of documents. Only that information is what is the knowledge of the LLM, right? So that is why if you see any LLM model, OpenAI or anyone, they will have a knowledge cutoff date. So that knowledge cutoff date says that they have taken only the information until that point. So this LLM model is trained with information that was available only until that cutoff date, right? So any information that comes after that cutoff date is not available, or any information that was not fed in during the training process is not available on the knowledge of that LLM. So now you understand what's the knowledge of the LLM, right? So how the knowledge of the LLM is built. That is based on the documents that they have trained, and only until that point to which it is trained. So what comes after that is, as I said, further training to answer questions from these documents. So answer questions is like, okay, if I ask a question like, what is the color of sky? Then you should answer like the color of sky is blue. And if I ask like, what is the color of sky in the evening? Then it should answer like this, the color of sky is red in the evening. So this is how they have trained. This is called instruct models, right? The base model, completion models are purely predicting the next word. The instruct that comes after that, so instructing it to do something, right? So you are asking a question and you are instructing that to answer that question. So this is called further tuning on the base model, and this becomes another base model, right? So this is what we are using. So what we are using in chat gpt, in meta, in gemini, everything is an instruct model that was built out of a completion model that can answer questions, right? That can generate responses for a given question. So this responses comes from the knowledge it knows. So what is the knowledge it knows? It is on the documents it was trained until that cutoff date. So there ends the knowledge of the LLM. Now, so how can we make it work for a specific use case that we want, right? Let's say we want to build a chatbot for EC group, and that knows everything about EC group, policies about EC group, your leave policies, your compensation policies, and everything that you can ask any question that you can ask a HR, you can go and ask a chatbot, and it should be able to provide the data. Can ChatGPT or Meta do that? Anybody can answer that? Yes or no?
No.
No. So why it cannot answer?
It may not have data specific to EC group.
Exactly. So it will not have, because you have not posted this on public forum. So there is no way anybody could have got these documents and learned about EC group. Only if you are posting any publicly available information that is available on the web, and that can be taken for training. So those LLM models were not trained on specific data that EC group has. So then how can we make a chatbot that can work specifically for EC group's information? So that is where RAG comes in. So we will go into that part. So let me share my screen. Able to see my screen? Okay. So I've just structured it with some small concepts. So we'll go by one by one. So first, we have just understood about the large language model. So what is a large language model? So basically, a large language model is a massive neural network. It is built, there is a lot of work, lot of GPUs went in building that neural networks, and it was trained on vast amount of public internet data. We just discussed that, and its core function is about predicting statistically probable next word. What is the probability of the highest probable next word? So again, the sentence, the sky is, then next word blue is the most probable. But if you say in the evening the sky is, then blue is not probable, right? Red becomes probable. So this makes a difference. So what you are giving as a input makes a difference to predict the next word. So it's the LLM's core function is to understand, okay, you are asking in the context of a evening. You are asking generally. So generally sky is blue, but in the evening it may be red, right? So that's how LLM works. The core functionality is predicting the statistically probable next word, right? It does. You can call it as a sophisticated auto completion system. So whatever your auto completion you are currently seeing in your email drafting systems, messaging systems, and everywhere, you type something and it is auto completing exactly what the LLM is doing the same thing. So it learns patterns and relationships from whatever it has learned, not necessarily facts. So it need not be a fact, right? So whatever it predicts need not be a fact. It's based on a pattern. You're asking about evening. Every evening is the sky red? No, right? But mostly, uh, you know, uh, uh, um, you know, uh, comparing to the morning and other daytime, evening it's little red. So that's how it will, understand the patterns. You are asking about morning, you are asking about evening, what is the relationship, and those things, and it will predict the next word, and it need not be a fact. Okay. So that's the core idea about LLM, normal LLM. So if you are using a normal LLM, that is what the LLM is, what is behind a chatbot, any chat GPT or Meta or anything. And this is what it is doing. Now, we need to make it work for our use case, and that is where RAG comes in. We will see that. So now with LLM, there are some limitations. So what are the limitations? The limitations are the knowledge cutoff. As we said, until the point it was trained, that is the knowledge. There is no further knowledge available for it. And LLMs are very good at, making you believe that it knows everything, right? That is what is hallucination. So it will generate factually incorrect information, even though it does not have any knowledge about. Why it does that? It is trained to do that. It's trained to do predict, right? Predict the next word. It is simply just going to, based on all the information that it already has, it is going to predict the next word. It need not be a truth, or it need not be an information that it already has, but based on what it has seen in the books, textbooks, and documentation, journals, and magazines, and everything, it will come up with its own story, unless it has some exact information. If it does not have that exact information, it is just going to hallucinate. It is just going to say, if you ask, how is the weather today, it may say, hey, weather is good, or it may say whether it's very sunny. It will not go and check what is the actual weather. It may just give you a response because it is trained to give you a response. It does not train to fact check. It does not train to see and fetch the exact information where it is available. A plain LLM model is just a talking model where it can chat with you. It doesn't matter whether it knows the information or not, it will hallucinate. So it is not going to be helpful. So let's say you are asking something about EC group, it may not say I don't know. It can tell you some hallucinated information which is not right. Okay, and again, there are parameters that can define whether it can hallucinate, whether it can be imaginative, be creative and all. So that is separate. So you can control those parameters to get your responses accordingly. But overall, this is what is an LLM is supposed to do. It will hallucinate, and there is no transparency. There's no citable information. So if it says that okay, you ask somebody else, somebody outside our company goes and asks about hey, what is the notice period in EC group, uh, though it may not know the information, it may just say 3 months. Maybe 3 months is common across many companies, and it may just say there is nothing to verify that it is 3 months. It cannot say this document from EC group says 3 months is the notice period. No, it cannot do that because it does not have that information. And definitely it cannot answer based on proprietary knowledge. What is a proprietary knowledge? Anything that is specific, internal to the company, internal to which is not available in the public domain. That is called proprietary knowledge. It cannot answer. So these are the main limitations, and this is what we are trying to address through RAG. So any questions until this point on understanding LLMs and its limitations? Okay, I assume there is no question. So we will now go into how RAG is going to help us here in overcoming this limitation. So let's do. So what is RAG? So RAG is nothing but architectural technique that combines LLM generative power with verifiable and external knowledge source. So basically RAG means retrieval augmented generation. It is, you are going to retrieve the information. So the knowledge is available somewhere. So you know where to retrieve. So let's say you have posted all your documents, all EC group documents in a secured drive, and you have access keys to access the drive. And if LLM wants, it can go and take that information. From that information, it can answer. If we are able to make that LLM work this way, then we will be able to achieve what we want, like accurate answers about the proprietary knowledge information that we have, because the source of information is available for it to answer. So we are instructing it to, hey, don't just answer by what you know. Here is information, go get it and refer it and answer, provide the answer to the user. So if we can make that work, that is what is RAG. So retrieval augmented generation. So LLM was just doing generation. Now we are going to augment that generation by doing retrieval. Understood, right? So that is what is RAG. Augment means what? Add some information to the prompt. So you are asking a question. Say, what is the leave policy in EC group? That's the question, right? So how can we augment this information, augment this prompt for LLM to answer? Let's say I ask this question, I cannot expect exact answer. Now, if I go and attach a document, this is the document that talks about policy, EC group's policy. From this document, can you find out what is a leave policy, right? And then it has plenty of information to look at. So now it will know that, okay, the user is asking this question. This document contains so much of information. From this information, let's say this document contains all the policies, right? All the policies of EC group. And it can go and find where exactly leave policy information is available. From that leave policy information, it can find the answer for your question. And it can respond, hey, this is the leave policy about EC group, so and so information is available. And it can even cite, this is a document I referred, and page number 15 has this information. So now you have a very accurate answer, very reliable answer, verifiable answer, which you can be sure that you are not giving a wrong information. So that is what is RAG. Any questions on this concept? Okay. So now let's go to how actually RAG, overcomes these limitations, right? So currency, like, it can provide up-to-date information because you are going to augment your question with up-to-date information. So your response also can be up-to-date. Factuality and trust. So it can reduce the hallucinations. It need not, hallucinate. It already has that information to provide, and provide you. Citations can be provided. Uh, References can be given. This is where I, took this information, and it can answer specific to that domain. It can, just, uh, provide you. So your LLM can be made used for many different domains, which has specific domain knowledge and so on. So that is how you are, overcoming the limitations. So some examples of RAG applications we have just spoke about, HR policies. So internal knowledge-based chatbots of HR policies, customer support bots, so product manuals. So let's say there can be a chatbot product for people who are site engineers, right? So site engineers, they are fitting or making some changes to the products that is. Or maintaining some products. They have some question about the product. They want to quickly refer about that product information, how to fix a specific problem. So this chat bot can be used, where if you have your knowledge base updated with all the product information, how to fix problems in that and so on, you can just ask a question and it can provide you answers then and there without the site engineers wasting time and referring manuals, going, finding out where it is there and so on. So you'll have thousands of products, thousands of people will be, servicing outside, and every person may have a small question. Okay, this particular washing machine has, three screws, but one is missing. Is it actually three or four? Right? Looking at the product catalog, it can immediately tell, hey, this piece comes with four screws, but if you only see three, then there is something wrong. So that's the kind of help you can get immediately, without going to refer to your actual documents. So actually this is where many companies are using now the chatbots. Okay. And legal and research tools. So legal documentations and research. For research, you will have plenty of information to refer. So all these places, large corpus will be available, and querying will be a big problem, and the LLMs can help there with specific data. These informations, or this corpus is not available publicly, so you cannot use just simple LLM. You have to go with RAG to augment your responses. So that is what RAG is all about, right? Okay. So now, any questions until this point? Okay. If not, we will go into some foundational technical components, right? Okay. So now somebody in the beginning said about token, right? So now let's say we know how to do RAG, or we know that we need RAG, right? We know what is RAG. So we need to augment data. And how can we do that? How do we, actually get the LLM or the product talk to the LLM with augmented information? Right? There are many things to know about the LLM first. Many constraints an LLM has, right? So there is something called context window. Anybody who has used LLMs, or already working on any products that you're doing, any projects that you're doing, or learning about LLMs, can tell me about what is a context window first. What is a context window? Anybody can answer.
We
No one is
talk
ready to
about
answer.
If we talk about certain concept, or let's say I'm talking about a particular page and I'm asking a doubt on that. Let's say, let us take a cursor. We will say, have an active tab which will refer to the current page, and if we ask on doubts on that or explain it, it will be referring to that page. So here the context is the page. So
Okay. No, that is context.
okay,
I'm not asking about the context. I'm asking about context window. There is something called context window, right? Window. The window is very specific here.
okay.
In LLM terminology, uh, so what is a context window? If anybody has used LLMs for anything,
Yeah,
you know. If you don't know,
total total number of input tokens
uh-huh,
needed, and total number of reasoning tokens, and total number of output tokens, all
exactly.
combined. So it has a context window.
Exactly. Okay, good. So now going deep into the LLM, you are asking a question, it is responding an answer, but there is some limitation, right? There should be a window of how much it can take as a question and how much it can, respond, right? A context window is nothing but the total number of tokens. Token will come to token, but the total amount of data that it can handle in a particular conversation, in a particular chat. That is exactly the context window is. So now I said, you ask a question, let's say 5 words in the question, it is responding with the 10 words as a response, 15 words. Fine, this is well within a limit. And if let's assume that context window is 100 words, okay. If the context window is 100 words, you are asking a question with the 5 words, it is responding with the 10 words, 5 plus 10, 15. It's well within the limit. There is no problem. Okay. Now come to RAG. So now this you can ask a question, but information is not available with LLM. It needs context. It needs data. You need to augment through RAG. So you know that okay, I asked this question. What is the policy, leave policy in EC group? uh, I know that this is available in this document. So this document is a policy document. This policy document is a 100-page document that has all the policies in it. Okay, so this 100-page document cannot fit into this context window because the context window here is only 100 words. Let's assume it is 100 words. So the information you can send is 5 words plus some 80 words as the augmented data, and remaining you have to leave it for it to answer, which may be 20 words. So that is the context window. If they say the context window is this much, um, that is the only amount of information that you can use for input and output. So input asking a question, output getting a question is not only the context, the information you are passing along with your question, that is also becoming a context here. Not only that, you will probably be sending the history of your conversation. So you would have asked 2 3 questions and you are asking a follow-up question. So the LLM needs to know about your history of the information that you have spoken and the context data that you are passing to respond. So all put together has to stay within a limit, right? So we call it tokens. So let's assume a token is a word. Okay, let's simply assume a token is a word, but token is more than a word. Uh, uh, to simplify, let's assume token is a word. Okay, LLMs comes with initially when it was started, it was like 1K. 1K means 1,000. And then slowly it gradually increased to 2K, 8K, 32K. Now, 256K until 256K it can go. So this is the amount of data that you can pass. So this is the amount of words that you can pass, right? So it is still a constrained amount. You cannot send a 100-page document on a 100K context window. So you can still convert 100K into words. It can come to around only 40 50 pages, not more than that, depending on the information available on a particular page. So let's approximately say 50 pages is the maximum pages that you can send, but you have this information sitting on a 100-page document, right? So that is the next constraint that we are having to solve. So now comes the concept of token, which is each word need not be a token. A complete word need not be a token, but in the LLM terminology, to understand words, to understand the meaning of the words, we use something called token. So what is a token? So token is a fundamental unit of text, LLM process. It can be words or part of words or punctuations, and it determines the cost of your, process. How much you are going to pay for each of your questions that you are asking, the response that you are getting, and how fast your response is going to be, or all these things are based on the tokens that you are using. So if you're using only less tokens, less cost, faster. If you are using too much of tokens, then it has to understand all the token, all the information that you have sent, formulate the response. If the response is big, again the tokens are high, and your response time is going to be slower. So this is something that we have to keep in mind. Token is nothing but that is the key determinator of the speed and cost of your conversation or your chat with LLM. Okay, so to give a brief idea, we've seen what is RAG. Let's see this part. Okay, OpenAI, if you go to OpenAI platform, you can see, you can actually see, what is a token, and you can visualize that. So I've just taken a screenshot of that. This is the text. Okay, this is the text that I have given, and this is the split up of token. You can see that OpenAI hyphen or apostrophe s is as a word. Here it is taken as open is one token. A apostrophe A is actually one token. Apostrophe is one token. S is one token, and then large is another token. And you can see comma, full stops, and all these are different tokens. Overall, 268 characters are probably 50-60 words. That comes to 49 tokens. On a thumb rule, you can say approximately 4 characters of text for a token, or this translates to roughly 3 by 4th of a word. 100 tokens is equal to 75 words. Okay, so approximately 50 words, 50 tokens is equal to how much? 30, 35 or 34 words. That's the idea behind tokens. So any questions on understanding tokens here? Why this is called as token? Because you can even within a specific word, you can split the words and have different meanings. Okay, so that helps LLM to understand things better. Okay. um, okay, any questions on this? Okay, let's go back. Now we know about token. So this tokens is we need to fit into the number of available tokens for your RAG, right? For your LLM conversation. So how can we now there is a question in this 100 page. I need to restrict my information that I send to OpenAI, send to the LLM to specific. Let's say 50 page, maximum 50 pages only I can send. So I cannot send the entire document. So I need to fetch at the max, like top probable 50 pages that contains this policy information. Correct? Top probable 50 pages that contains this information. How can I do that? So I need to go for identifying what is relevant in this document for the question that I asked. So I asked about leave policy. First page talks about index, doesn't matter. I don't need. Second page talks about festivals, no problem. Third page talks about some other HR policies and things like that. And there are 10 different pages that closely relates to leave policies, right? So I need to find that. I need to find from this 100 pages, I need to find those pages and send only those. If I only send, instead of 50 pages, let's say I want to save cost also, I want to send only 10 pages. Even though 50 pages is allowed, I don't want to just load it with 50 pages, because 50 pages is going to cost me $2. If I send only 10 pages, my question can be answered in 2 cents. Okay, that's good, right? So I need to ensure I fetch relevant information from this document somehow, so that I can send it to LLM with my question. And this is one, I'm talking about one document. There can be thousands of documents available on UC Group. So I first need to find out that, policy document is the document that I need. On the policy document, these are the pages that are relevant. Fetch that and send it, right? Now imagine for a corporate, world, or any company, you want to enable this chatbot, or in the case of a product thing, you have thousands of products, thousands of different people using it, many manuals, right? You have to find out what exactly they are talking about and give it, and it's all natural language, right? So they are going to ask you about I am on the washing machine model 1234. I want to know this thing. This is the exact information. This is what probably they'll be giving. So you will have to restrict from all your products to washing machine, from washing machine to a specific model. From that specific model, you need to find the policy, the product manual. From the product manual, you need to pass limited information. So this is what, the problem you're trying to solve with the RAG. So implementing RAG involves solving these problems, right? Not only just sending data is RAG, that's all. I mean, there's nothing more than that. But how can you effectively and efficiently send this data, find this data first, and then augment your prompt, so that you get you can get the response, as well as at the same time you can control your cost, you can make it faster, and so on, right? So that is where the concept of identifying the specific information comes to play. So how can we identify? Can somebody tell me how will you, if you don't know about anything about LLMs, you have 10 pages. Somebody is asking, sorry, 100 pages. Somebody is asking you to find the pages where leave policy is available. Quickly, you need to find it. What will you do?
Indexing.
No, I'm not talking about you. You are just sitting in your laptop. Kavita has given you, hey, this is the policy document. You are helping Kavita, okay?
Okay.
This is the policy document. Can you find out which page we talk about leave policy? I need immediately. Can you tell me? So what will you do first?
Find.
You will do a find. You will do a keyword match. So you will just do a find, put the keyword policy or a leave policy, and try to find that. This is the basic, find you will do. So now let's think about this problem. Somebody is asking a question. Give me a code in Python to find something, right? I'm just saying, give me a code in Python. Another person is saying, can I have Python as my pet? Okay. So these two things are talking about Python. Okay. But one is talking about Python as a programming language. One is talking about a snake, right? So these two things, if you go and find Python in your document repository, you will find both the documents. You will not know which one to pick. You will probably, take everything. You have to understand. So there comes, another kind of searching called semantic search. So what is a semantic search? Semantic search is meaningful search. So search based on the meaning of a word or a keyword or a sentence or anything, rather than just looking at the word itself or the sentence itself, right? So this is what is how can you do that? You need to find the meaning of it. So where is the meaning of it? You cannot go to the dictionary and find. That is not the case. So in LLM world, we have something called vectors, embeddings. Okay. So vector is nothing but a translation of a word into a number. Not only a word, it can be a sentence in relation to. So this number is in relation to another, other words. So you take thousands of parameters as your properties. Let's say uh, animal is one property, programming language is one property, book is a property, and like this you have so many things. So if you take Python as a snake, then you will this Python, you will say programming language is closer to this, and it's not an animal. You will put one on the programming language, zero on the animal. Another Python, you will say animal is one, programming language is C. So you have now two Pythons, but Python 1 is actually meaningful in terms of more closer to programming language. Another Python you have that is meaningful to an animal. So just by having this Python as a word, you cannot do. But if you put other words in line and search, so I want code in Python. So code Python talks about programming language. Python pet talks about an animal. So you get a closer match there. So that is the idea behind semantics. That is what semantic search is. So you search a particular thing based on the meaning it gives or the relationship it has between the other things. So a vector is nothing but you convert each token into a vector, right? You convert each token into a vector, and this combined list of tokens are taken and searched against all the available documents. So this is simply understand like this. Okay, um, you have this document, 100-page document. So now you need to identify this 10 pages or information that is available. So what you will do, you will take this page, you will split that, you will take this document, you will split the document into pages, or you will split the document into paragraphs, or you will split it into sentences. Any way you can split. So how you are going to split, that depends on your general use case, I would say. Splitting, as you can even split into words, you can even split into a sentence, you can split into a paragraph. But what makes more sense is the beauty spot you need to find. You can even split as pages. When you split a document or when you split a file that contains programming language or code, it's better you split as separate functions, because each function means separate thing. If you are splitting a document that is a story, right, a novel, each chapter, and within a chapter each paragraph may make sense, because one paragraph may be conveying a specific information or specific mood or something, right? So that is meaningful. Splitting as a paragraph in a novel is meaningful. Splitting as a page, let's say you have hundreds of forms filled, okay, each page containing a form. So then in this case, splitting as a page makes more sense, because this page contains this form, another page contains another form, right? So that is what is about chunking process. You will first, you will chunk your document into, split your document into different pieces, okay, and all these different pieces, now you are going to create a vector or embedding. So this vector is nothing but, I said, converting into meaningful numbers. So this is going to sit in a map. Okay, so I will just show you one example there. Where do I have that? It's not available. Okay, I assume that in a map, you will have let's browse it. But oh, this is one good example. see here. So in this case, a male female graph. So man king or in the space, right? On one side, woman queen or on the other side, because they are, queen is closer to woman, king is closer to man. Same way, you visualize this in a 3D space. It is not 3D. It is multi-dimensional, 1,000 dimensions. Okay, whenever you create a vector, it is of 1,000 dimensions or more than that. So this is simply showing a three-dimensional figure, but assume that it is in 1,000 dimensional space. How each will be kept. So you have split all your documents, and all the documents are. So this is a list of numbers here. So you all the documents are available in the space. Okay, but these paragraphs, whatever, let's say you have split like paragraphs, all these paragraphs will be a paragraph talking about a specific thing, and another paragraph talking about a similar thing will be closer. Okay, so a page talking about leave policy and a page talking about leave something else about leave, they will be closer than something talks about festivals, right? So that is how this semantic embedding will be. Embedding is nothing but you create these. You have taken this document, converted them into different paragraphs. These different paragraphs, you are embedding them, like you are converting them to vector, and you are storing that vectors in a space, right? So all these are available, and when you ask a question about leave policy, it is again going to convert your question. I want to know about leave policy. This is again converted to a vector, and it's going to see which vector is close or where is it going to fit in this entire space. So it is going to take the closest available vectors, which are the paragraphs. It can be any paragraph from the document, but anything that is closer to this one question vector that you have asked. Let's say 10 different things available like this, right? So there are many available outside, but these 10 are the most closer. So this 10 is what is going to be taken. In this 10, this particular one can be in page 1, and the next one can be in page 5. That may still be talking about the policy. Another one can be in page 20. That may still be talking about the policy. So you have exactly picked all the paragraphs that specifically talk about leave policy, and this is what you want. So you now have this 10 paragraphs from this 100-page document, and you are now going to say, hey LLM, these are the different 10 paragraphs I have found or can contain some information that can answer this question. Using this information, and you answer my question. So now LLM will be able to answer you. You have uh, overcome the restriction of staying within the limit. You have overcome the restriction of finding a particular information from your document, right? And adding it to your LLM. So this is exactly what a vector is. So it's a list of numbers, and it represents meaning context of a text chunk. A chunk is nothing but, as I said, it can be a paragraph, it can be a sentence, it can be a page. It depends on how you are chunking your document, right? So there are many ways to chunk. Split, it is outside the scope of the LLM. You can extract the data. You can use your program to identify. Okay, I want to do a split based on a line space. I want to split whenever I see a dot. I want to split whenever I see a page break. It depends. Okay, you just split it. You convert it to a vector. So how to convert it to a vector? We'll come to that. But let's say you convert it to a vector, have it available somewhere. You ask a question, find out the vectors that are matched, and before that, you ask a question, you convert this question as a vector as well. And this vector, there are thousands of vectors sitting on the space. See what is closer. Take only the most, the top 10 closest matching vectors. Send it to you are taking the vector means that, I mean, you are taking the corresponding text out of it. Okay, not exactly the vector. You are not going to send the numbers to LLM. You are just going to take the corresponding text out of it, end of the day, you can send only text to LLM. Right? You have asked question in text. That question is converted to numbers, that is vectors. This numbers is compared against a set of numbers, and that number you have taken, and from that number you are extracting again text. Okay, how will you extract? It is not like conversion and all. You will probably store this text information as a metadata on each of the vector embedding. Okay, so and you are just going to take that and take the metadata of that and pass it to LLM. Okay, clear? Any questions? Okay, so how can you create this vector? That is something called embedding model. Every provider or like the LLM is a completion model or a instruct model, as we said, but there are models that can create embeddings. Okay, so embeddings is nothing but converting your words to tokens, and from tokens to vectors. It will create and give you back the numbers. There are models available. Even OpenAI has embedding models. In open source, there are plenty of models available. It is just going to tokenize and create a vector and give you. And then, okay, this embedding models give you the numbers, and you need to store it somewhere, right? So you need to store it somewhere. You need a database to store it. So that is what is a vector database. So now comes another point, another concept of, we know about we need to create vectors. We know about only by searching, only doing a semantic search, meaningful search, we can find relevant information. Okay, we got the model, we have converted our text to numbers, but this has to be stored somewhere. And to do the semantic search, there is some technique involved, and we need to extract text out of it, right? So this process is the next step. That next step, vector database, is nothing but a database provisioned to contain vectors as the records. So how you store a particular row or row in a RDS table, SQL table, or a JSON object in a NoSQL table, right? Similarly, you need to have a place where you can store this vector, this is going to be huge, right? A 4-line word or sentence, which is, if you count the bytes of it, you may just less than 100 bytes. Okay, but when it converts to vector, okay, it is compared against 1000 parameters by 1000 parameters. Okay, which is going to be close to 1 MB of data. One little sentence, when it converted to a vector, that vector is going to be 1 MB of data. Okay, irrespective of the data, the sentence you have, you can have a paragraph, you can have a page. This entire page of information is going to be converted to a meaningful mapping. It is not about numbers. It's a mapping in multi-dimensional space that says puts ones and zeros in each dimension, right? So that is what is a vector. It's not going to these amount of data is not going to change. Amount of bytes is not going to change just because your entire data is changing. It is still going to be that 1000 by 1000 dimension, right? So 1 MB, any number of text that you put, that's going to be 1 MB. So every record 1 MB. I'm just giving a ballpark 1 MB. It can be more than or less than that, depending on the dimensions. So you need a database that stores this information, and your database should be provisioned to operate for that. So that is where specialized vector databases are coming in. So there are a few examples, like Quadrant is one vector database you can use. It's an open source thing, I believe. You can use locally. There are third-party databases available, like Pinecone and so on. Okay, so they are specialized in. I'll show you Pinecone. This is what we use in our product. It's a ready to use. You don't have to spend time developing, building your database, managing your database, and worrying your database, writing queries, and so on. It is like a product that is available. You can just plug and play. You can use this vector. Once you create your embeddings, you can store the information in a vector database. Pinecone is the place. I'm saying this because it provides free versions also. I mean, for startup versions also, where if you want to experiment without spending too much time on managing these things, you can go to Pinecone, create your own account, create your own indexes, experiment with it. So that will be helpful. As you said, Kavita, you are going to have some hackathons coming up. This will be helpful for people to use it. Okay, so you can just go and check this out. Okay. So now that is what is a vector DB. So you can store these embeddings. They have specialized processes that will do semantic search on the embeddings that are available, and very quickly they can find out, even if there are millions of records available for a question that you are asking, it can find exactly the top matching. You have to just say, I want top 10 matching vectors. I want top 50 matching vectors. It can pull that vectors, and you will store your data as metadata into that, and you will extract the text from that and use it, right? So that's exactly what a vector database is. We know why RAG is needed. We know what we need to do on the document. We have chunked the document. Text is available. We have converted to a vector using an embedding model. Now this vector is we stored in vector database. We have different options available. So we store there, and we now know this information is available there, and I can retrieve the information from there. Okay, so this is all about. So this is a specialized database for high dimensional vectors, and the purpose is for nearest neighbor search. Okay, fast nearest neighbor search. As I said, closest meaningful vectors can be found. Find semantically most similar document chunks. This is exactly what it's doing. Any questions?
The pine cone will convert the given text into um, embedding number, the vector numbers, or
No.
it will. Okay.
Okay. So that is where these two things are separate. Okay. So this embedding model is going to create that vector. Okay. You need to create a vector. What is a vector? It's a multidimensional number. Okay. An array of numbers. You can call it an array of numbers. Any uh, text you give, that will be converted to an array of 1000 by 1000 array matrix. Okay, 1000 by 1000 matrix number is going to be created. That is created by this embedding model. Okay, Pinecone or anything vector database does not come there. It is creating data. Creating data is done by somebody. Okay, that is embedding model. So you create the data. The data is the 1000 by 1000, matrix. Now this matrix data has to be stored somewhere. So vector DB or Pinecone is a storage place. You store the data there. Okay. So
Okay.
if you
So
look at this data, you will
my
understand this. Yeah.
what is the embedding model? We have any open source embedding model to
There are
convert?
there are different ways of embeddings available. Okay, OpenAI provides their own embedding model. It depends on your use case. You can find out in Hugging Face there are many embedding models available. Okay, so let's go to
Yeah.
Hugging Face and see. Hugging Face is a place where many all open source models are available. You can go to models and you can see, search for embedding. Google has embedding gamma. Okay, So this is an embedding model that you can see about what is the dimension it is going to give and so on. Okay, the dimension size is 760, smaller options available. There are many different options available. You can, if you are doing it 128 by 128, then it is not going to differentiate too much. Okay, your accuracy depends on the or the meaning, finding the actual meaning, comparing against the meaning is going to vary, or is proportional to the size of the dimension. If your dimension is high, your accuracy is going to be high. If your dimension is small, your accuracy is going to be small. Okay.
Okay. So we have to host the, let's say, customer wants some document to be racked, and he has a document or some books or something like that, and he wanted to do it as a private, that does not depend on any um, cloud supported, I mean OpenAI related directly. They can download the Hugging Face or something like that. So from
This
uh,
is again, what I showed you is an embedding model. What
yeah,
is an embedding model? Model is the creator.
okay,
It's going to output the data,
numbers.
numbers. You have to store the number somewhere. Okay,
Yes,
so to store the number somewhere, you have different options. That is, one
vector
is
DB.
Pinecone, which is cloud. You can third party cloud. Like that, there are multiple things available. Quadrant is a kind of database that you can locally build and store. Then you have to write all the queries that are needed for getting the semantic search. Okay, even Postgres now has a PG vector, which is Postgres vector for storing vector database and searching vector databases. Okay, so there are different options available.
Okay, so to do it in a local and to host it, is there any roadmap or how to do it for a for learning also? It could be from
I will say to
starting.
start with use third-party tools. Okay, then you will understand exactly what it is. Okay, then you can go for in-house things. Use Quadrant, or documentation is available on those things. It is very straightforward. Okay, like
Oh,
how you do a SQL search, this is going to be a vector search. Store the data, search the data. This is the concept behind every database, right?
yeah,
Yeah.
thank you.
Good question. Any other questions? Okay. Now let's go into. So we have spoken about the semantic search. So what is a semantic search? It focuses on intent and contextual meaning of a query. So now you have, let's say you have stored the data in the vector database and you need to search. You are asking a question that has to be converted to a vector set of numbers, and this vector has to be matched against all available vectors. That is what a semantic search, meaningful search. And you will, your query is converted to vector, and it will search the vector database for closest matching vectors and give you the result. And you take that from the resulting vectors, you take the attached or corresponding text, which is the paragraphs or sentences. You go to LL. Okay, so that's the foundation. Any questions? Can we go to the next part? Okay, now let's see how to implement a RAG. So implementation, we just already spoken, but these are the steps. Preparation, chunking your documents. You have to chunk your document, which is like split your document. It depends on how your use cases. As I said, if it is a form, split by pages. If it is code, split by functions. If it is a general document, just go by paragraphs or sentences. It depends on the use case. You just have to chunk it smaller pieces so that it can fit into, you can find meaningful smaller pieces from a document, and those meaningful smaller pieces can be easily searched when you are asking about that. Indexing is nothing but vectorizing, changing that, once you have the chunked data, which is small text. Indexing is nothing but vectorizing that. Using an embedding model, you change that to vectors. Then store it in a database, vector database. And then retrieving. So retrieving is where the semantic search comes. You're asking a question, that question has to be converted again to vector, and that vector is searched against multiple vectors, and it is gathered. And then finally you give it to LLM, like, this is my question, these are the supporting data, which is like 10 paragraphs, and this stays well within the token limit, and the LLM will be able to answer you. That is the generation part. So you have retrieved data. After retrieving, you have augmented the data by adding it to your prompt or question, and then you are generating the response. This is retrieval augmented generation. That's it. Questions? So yeah, common ways to implement, like, there are third-party solutions, as I said, Pinecone. In-house solutions, which is like you can create your own vector database, have your own queries built to search, to do semantic search on vector databases. That is in-house. Pros and cons are like third party, faster setup immediately. Today, just sign up and you have it available. Use an API to store the data, fetch the data. Less customizations, and it has vendor dependency. So you have to, these are the dependencies. In-house, you have maximum control. You can tailor, but it has, high development cost, and specialized expertise is needed, because you need to know what's the vector database. Somebody has to manage it. Somebody has to write queries. Somebody has to, upgrade this and so on. So that is all needed. And still, there are some constraints and limitations with RAG. RAG is not the only solution to all the problems, right? Because there are many other things outside RAG or apart from RAG, which you may need for specialized use cases. So some of the constraints here are preparing the data. Output depends on the source data quality. So you have to decide how you are going to chunk, how your data can be kept. In some cases, or in many cases, overlapping will be needed. For example, if you are taking a novel, right, and the novel goes through a line of story, right? Page 1, page 2, page 3, page 4, you are going to chunk everything separately, and you are going to store it. You need something to link. Okay, this is page 1, after this page 2 comes. Page 1 and page 2 are closer to each other, because it comes one after the other. So in this case, you will do some overlapping. Okay, so overlapping in the sense, you will take some data from the page 1 and add it to the page 2, so that same information is available in both the places, and by that you make them have some common information, and you can make it closer. You can make it, force it to be closer to each other, like this. So in this sentence, if you see, if you are chunking the sentence into three parts, chunk 1, chunk 2, and chunk 3. Chunk 1 says, this is the text I would like, right, to chunk up. So until this point, or you will do chunk. And chunk 2 also, you will start from 2 chunk up and go to this point. So this is the overlap. So you will put this overlapping in both chunk 1 and chunk 2. Similarly, chunk 2 and chunk 3 will have some overlap. So this way you will have a chain of data coming with overlaps. So that way your retrieval accuracy will be better. So these are all different techniques that you will follow to make your data more reliable, right? And setup. So as I said, if you are implementing on your own, it will need setup complexity. And main thing, latency, right? Retrieval step adds time. So there is a huge difference between you are asking a question directly to LLM response. That is going to be like this, faster. But if you have to do a process before you even ask a question, you go find out this information, find the top 10 matching data, then add it to your question, then send it to LLM. there itself you are going to add some latency, 2-3 seconds to your response. So whenever you are having a RAG, you will definitely see your responses will not be that immediate because you have to do this process first, right? Latency and cost, again, managing this data and other things, you have additional cost. Limitations is nothing but what it cannot do. So your data is poor, then your quality of answer is also going to be poor. And if you are not able to find the right, your data may be there in RAG, okay, but if you are not able to find the right data that matches through this mechanism I said, then also you are going to have poor results, right? It all doesn't mean that just because you have your data in your RAG system or the vector database, you are always going to have your information. There are cases we have seen, like because there are also a limitation, right? You can only fetch only top 10, 20, 30, 50 maximum records to send. What if your all uh, records are closer or same meaning, okay, only with some small changes, like when it comes to numericals, right? When it comes to numbers have no meaning, right? In that case, you even drag semantic search will find it difficult to get right information, okay? So because everything will be in the same space, but top 50 may not have the data you are looking for. So there are some limitations there. So those has to be dealt separately. These are some constraints and limitations that you will probably have to see. RAG may not be the solution here. We may have to have a different solutions like graph databases. You may have to use these as structured data, extract structured information from this, store it and use it through other tools and so on. Okay, that is outside of the scope. We will not go into that now. But they are limitations. RAG is not the only solution. Okay, and requires maintenance. Indexes must be constantly updated. So vector, like table we call in a database, we call indexes in vectors, the databases. So they have to be constantly updated, maintained. You need to add metadatas to filter them. Just doing semantic search may not be enough. You may have to, even in the semantic search, you may have to apply some filters so that you just do semantic search only on a specific set of vectors. For example, you have a school database, books, right? You have books of class 10, class 11, class 12, and you are asking a question for class 12, and you want to search from the books available for class 12. All these are sitting in the vector database. Class 10 also has the same subject or a lesson about in a botany, same information. Class 12 has little more information, a same kind of lesson. Okay, so you want the response only from class 12, you don't want the response from class 10. So this is where your vectors sitting on the database have to have some metadata saying that okay, this all these chunks or vectors belong to class 10. These chunks belong to class 12. So you can say search the vector database, but use this filter, metadata filter, that class has to be 12. So you give metadata as well as your text, then it filters out class 12 only, and then from that it fetches relevant information. So those are some things that you will have to be aware of. That's all about the constraints and limitations. Any questions? Okay. So there are multiple architectures available in RAG. Some three main things are naive RAG, which is simple initial query retrieving the vector. Okay, so this is the first thing you will start with naive RAG. You have vectors, you have question, change the question to a vector, get the matching top 10, top 50 records, use it. Simple, right? But this may not be, as I said, there are many use cases where this may not be right. So you may have to go for advanced RAG techniques. So what is advanced RAG techniques? your question, you may have to enrich your question with more information so that you find more relevant data. Okay, for example, let me ask you this. Let me ask a question like, uh, when is Christmas celebrated? That's the question, right? So there are many documents talking about Christmas. I want to, so if I am asking about Christmas, I may be asking about some other information like how Christmas is celebrated, what should I do for Christmas, and there are many things. So you can enrich your question with additional questions, additional keywords that will be able to find more relevant information from available documents. So that is something that will help, because a simple question, a one line question, though it is a right question, may not be enough to find what you want to respond, right? So you may probably generate a dummy response and say, I want to know if you can use an LLM to enrich your question. This is the question, add more information to the question so that I get more relevant information. So this is one step, added step that you will do before going straight with your question. So again, it will add more time, more cost and things, but end of the day, your responses will be richer. Okay, so that is advanced RAG. Re-ranking documents is nothing but you have got 50 documents. Okay, but in this 50 documents, you may have to rank it further to eliminate some of the things that are not needed and send only what is relevant, or do a different search again with a different question based on the re-ranking that you have done, so that you have more relevant information gathered. So those are some advanced concepts that you will have to try. And modular multi-hop RAG is like, multi-step retrieval steps. As I said, retrieve some information first based on the available information, go further and more retrieval, do on more specific data from the first response, so that you use an internal reasoning system to see until you get your required data, and then finally answer your uh, user. So these are different ways you can implement RAG solutions. Start with NaveRAG, and then based on the use case, you will gradually, I mean, once you start using it for a production application or a client use case, you will automatically face challenges that NaveRAG is not sufficient. So you will go for additional things. So any questions on that? So now comes the future of RAG. After RAG, what next after RAG? So you can implement self correction or self RAG, internally answering questions, and integrate it with other tools like agents. As I said, RAG is not the only solution. You may have to use other tools. Tools are like functions, you can call APIs, you can call. For example, you have your database of your client connected. Let's say a customer order information is available in a database. Okay, to get the order information of a specific user's order, you will not go for RAG, because that information is RAG is only for documents, right? This information is live information that's going to keep on updating. So you will have to use an API to fetch data from a particular table, get the data, and use it along with your RAG, right? So that is called tools. That is where agents come in. Agent is nothing but doing a specific task, like calling a function, calling an API, or calling, using code interpreter to generate code and generate data out of it. There are other things, and you can do fine tuning is another concept. So to enrich your response, to to change the behavior of your response in a way. So fine tuning can be done. So you can combine fine tuning and RAG to satisfy your customers' needs and so on. So those are actually the future steps once you implement RAG. So I did not do any coding part here because that's going to be too technical.